Now let's move on to the cranial dura mater and the dural venous sinuses. When we say the word cranial dura mater, we are specifically talking about the dura mater in the cranial cavity because the dura mater in the spinal level is very different from the cranial. The unique thing about the cranial dura mater is, unlike spinal dura mater, the cranial dura mater is having two layers. One layer of dura mater is adherent to the skull bone, and other layer of the dura mater is going along with the different part in the gyra and sulci, and not the gyra sulci, actually the major fissures of the brain. So one close to the brain and one is close to the bone, and that's how we call the endostal layer and the meningeal layer of dura mater. So what I'm saying is that cranial dura is having two layers. We got the endostal layer and we got meningeal layer. Now let me explain that diagrammatically, guys. If you take a coronal section from the skull, or simply let's say there's a skull bone you're looking at. Let's presume this be a coronal section. So that's a bone, that's a skull bone. So we have one layer of the dura mater, cranial dura mater, which is adherent to the bone only. Which is adherent to the bone. This is called as endostal layer. We can call it periostal layer also, but the periostal word makes more sense when you see it from the outside. So outside we have periosteum on the inner aspect toward the cranial cavity. The better term is endostal. Although many authors call it periostal layer, means the same only. And then we have meningeal layer. The meningeal layer is also running along with the endostal. It is running with the endostal layer in most of the places, but at some places you will see this meningeal layer will go with the major fissures in the brain. Will go with major fissures in the brain. So it basically separates itself from the meningeal layer, from the endostal layer, and will then go along with the brain, and that is the meningeal layer. So this here is the endostal layer, as you can see, adherent to the bone, and the one which is separating from it, this is the meningeal layer of the dura mater. So what you see, the place where these endostal and meningeal layers separate from each other, they enclose a space in between. This space that they enclose here are called as dural venous sinuses, and you can appreciate a dural venous sinus here as well. Now, the reason I made you draw this picture is so that you understand that dural venous sinuses are of also two types. You're looking at this dural venous sinus, I'm like DVS, dural venous sinus, which is present between the endostal and the meningeal layer, and that is the usual scenario. That most of the dural venous sinus are present between one layer is endostal, one is meningeal. But this is also possible to have a dural venous sinus present only and only in the meningeal layer. Now we have all around the meningeal layer present here. So we do have some dural venous sinuses which comes under this category, and there's a question on this as well, that out of like so many dural sinuses we have, which two sinuses, I kind of gave you the answer only, which two dural venous sinus comes into the category of which are present only in the meningeal layer of dura. So before we go into the endostal layer and about the dural venous sinus, which is of what type, we first have to understand that how these dural sinuses are formed. Out of the endostal meningeal layer, the one which is leaving the skull bone and going away is the meningeal layer. So that means all the dural folds we talk about, falx cerebri, falx cerebelli, tentorium cerebelli, all those, they are definitely made up of which layer only? The meningeal layer only, because that is the one which is moving away from the skull bone. So it's the meningeal layer of the dura mater. It's the meningeal layer of the dura mater which will give rise to the dural folds. It gives rise to the dural folds. What are the dural folds? The main dural folds includes the falx cerebri. We got falx cerebri. We have falx cerebelli. We got tentorium. Tentorium cerebelli. And then we have diaphragma cellae. Diaphragma cellae. It is basically covering the sella turcica and separating the pituitary gland from its stalk, so we call it diaphragma cellae. Okay. So these are the dural folds we have. Now, first of all, what is the meaning of this word falx? When you say the word falx, falx means sickle shaped. Something which is shaped like a sickle. So falx cerebri is something which is present between the two cerebral hemispheres. It is separating the two cerebral hemispheres. Then you say falx cerebelli. It's a sickle shaped fold which is present between the two cerebellar lobes. It's a very, very small fold present between the two cerebellar hemispheres. And then the term is tentorium cerebelli. Now look at the word tentorium and then we say cerebelli. That means it is a tent on the cerebellum. So we got a cerebellum like this, and there's a tent-like structure which is present on the cerebellum, separating the cerebellum from cerebellum. That's why we call it a tentorium cerebelli. Let's look at the picture here before we go any further and draw it. Look at this image, guys. This is a picture, a striatal section first, which is showing you this falx cerebri. You can see this huge fold here, dural fold, that is falx cerebri. Obviously, it is separating the right and the left cerebral hemisphere. A very small fold. Look at my hand here. This very small fold which I'm pointing at here. This is called as a falx cerebelli. This is between the two cerebral hemispheres, not separating them entirely, but extending between the two lobes, close to the vermis. And the one which is present in this plane, in this horizontal plane like this, that is called as tentorium. So above the tentorium we have falx cerebri, and below the tentorium we have the falx cerebelli. And of course you can see there are so many dural venous sinuses, you can see it already are in relation. Before we try to identify these dural venous sinuses, let's draw it schematically and understand. Then it will be easy for us to identify it on the picture also. Falx cerebri, look at this. That's how falx cerebri is present between the two cerebral hemispheres. And if it's a two-dimension, we can draw it in the two-dimension way. Horizontally placed is what? Horizontally placed is the tentorium. Now let's say this is the tentorium cerebelli. This is tentorium, and underneath the tentorium is the falx cerebelli. There's one. So I'm just going to highlight the two so that you can highlight this tentorium so that you can see one is above and one is below. This is tentorium, the one which is in the horizontal plane, and I'm going to highlight only this one. Right. So this is in the horizontal plane, and that's the one in the vertical plane. Let's not even label them because we still have to mark many sinuses there. The dural sinus, which you will see seen running along the upper margin and the lower margin of falx cerebri, because they are present in the sagittal plane, so we call them superior sagittal sinus and inferior sagittal sinus. So you will see a sinus running in like this, it's called a superior sagittal sinus. Make sure you keep drawing these arrows so that you remember what is the direction of the blood flow. And there is an inferior sagittal sinus which is running along the lower margin, reaching downward like this. Superior and inferior sagittal sinus. The inferior sagittal sinus, when it comes down, it drains into the sinus which takes the blood backward in this direction. It's taking the blood backward in the direction here, and this is called as the straight sinus. It is running backward straight, so we call it straight sinus. This is straight sinus. So superior is coming here, inferior is coming down, straight is taking the blood backward. So we have this point where more or less if you see all these direction of the arrow, the blood is coming almost here, at this point here, which is also receiving the blood from the sinus coming from the attached margin of falx cerebelli. Look at that. This also is sinus and it's taking the blood upward. Now what should be the name of this sinus, guys? This is related to what bone here? To the occipital bone. So the name given to the sinus is the occipital sinus. This is referred as the occipital sinus. So now this common point where the blood is being collected here is called as the confluence, the meeting point. This is called as a confluence of the sinuses. So majority of the sinuses are draining their blood and the blood getting collected at this point called as a confluence. Still the purpose is not solved. We have to take this blood from the confluence, take it out of the cranial cavity. Now how will you take out of the cranial cavity? The blood from the confluence region will now go into another sinus running in the attached margin of tentorium cerebelli. Look at this arrow once again. That's how the blood is running now. Ultimately, and this sinus is in the transverse plane, so simply we call it the transverse sinus. So all the blood has now come into what? Transverse sinus. Superior, inferior, straight, occipital comes in here, and ultimately blood goes into transverse sinus, but still not out of the cranial cavity. From the transverse sinus, finally, the blood goes into this sigmoid sinus. It goes into the sigmoid sinus, which is present in the sigmoid sulcus, sigmoid sinus, and sigmoid sinus is the one which goes out of the jugular foramen. Sigmoid sinus is the one which goes out of the jugular foramen. And as soon as it leaves the jugular foramen, it is joined by the other sinus to form a major vein here, and that major vein is internal jugular vein. So what is this other sinus? It is coming from the cavernous, we will discuss that. It's called as the inferior petrosal. This is inferior petrosal sinus. But there is a very important question to be noted here, and I request you to write down separately that sigmoid sinus and inferior petrosal sinus are the formative tributaries of internal jugular vein. They are the formative tributaries of internal jugular vein. Guys, for all the major veins in the body, you need to know at least their formative tributaries. If you don't know all the tributaries of internal jugular vein, that is still okay. But you cannot miss the formation, how they are formed. Formative tributary of internal jugular vein is by the sigmoid sinus and also by the inferior petrosal sinus. It is also imperative to note that if somebody asks you what is the content of the jugular foramen, never say internal jugular vein. Internal jugular vein is not the content of jugular foramen. The content of jugular foramen is 9th, 10th, 11th nerve. We discussed that in the cranial nerve. 9th, 10th, 11th nerve are coming out of it. And then these two formative tributaries. Sigmoid sinus and inferior petrosal sinus are the content of jugular foramen because the fusion, if you look at this diagram carefully, the fusion takes place just below the jugular foramen. The fusion takes place just below the jugular foramen. So internal jugular vein is not the content, its tributaries are the content. Okay, so before we go any further and understand this in a different way, I want you to look at the same diagram once again, the same picture again, and let's fetch the answer to the two questions in there. So if I take you back to the same sagittal section, it's easy to identify the sinuses here now, right? This is the superior sagittal sinus, of course. I'm writing S, and there is superior sagittal sinus. This is inferior sagittal sinus. This has to be the straight sinus. This is the confluence part, I'm writing C for the confluence. This is occipital sinus. You can see the occipital sinus which is taking the blood upward. And then we drew the diagram on this side. This is showing from the other side here. That is transverse. Can you see that blood is going to that sinus? That is transverse. And the transverse sinus is taking the blood downward into this one. That is sigmoid sinus. And you can see sigmoid sinus is going to fuse with this inferior petrosal sinus. You can see they both are the one going out of the jugular foramen. They both, it's the largest wave. Look at this. That's a sigmoid sinus going down, and that's the inferior petrosal coming in here, and they both will fuse with each other just below the level of jugular foramen. It's covered with the dura mater, so you can't see the jugular foramen clearly. Two questions for you here. Question number one, we said that out of all the neurovenous sinuses, two sinuses are present only in the meningeal layer of dura mater, the one which do not have contribution from endosterial layer. Well, how will you identify them? Well, the sinuses which are away from the bone. If a sinus is away from the bone, that means it has no contribution coming from the bone or from the endosterial layer. They are obviously made up of only meningeal layer, and those two sinuses are inferior sagittal sinus, it is away from the bone of course, and one is a straight sinus. Inferior sagittal sinus and straight sinus are present only in the meningeal layer of dura mater. They are present only in the meningeal layer of the dura mater. So please note that inferior sagittal sinus and straight sinus are present only in the meningeal layer of dura. And the second major question here is about, if you look at the straight sinus, it is receiving the inferior sagittal sinus, fine, but that is not forming it. Straight sinus is not formed by the inferior sagittal sinus. It is simply a tributary which is draining into it. The major contribution to the straight sinus comes from a vein. Can you see a vein over there? Let's look at this vein here. This vein is called as great cerebral vein, also called as the vein of Galen. We talked about the Galen's anastomosis in the vagus now. This is called as vein of Galen. So that's a vein of Galen or great cerebral vein which goes into the dura mater, and once it goes into the dura mater, it will continue in the dura mater as a straight sinus itself. So please also note that straight sinus is a continuation of great cerebral vein or vein of Galen. It's a continuation of great cerebral vein or vein of Galen. Okay. Now, if you understood this arrangement here, these sinuses, the other sinuses can be understood by looking at transverse section. If I see a transverse section of the cranial cavity, I want you to anticipate first when you see a transverse section what sinuses you can easily appreciate. In a transverse section, I can clearly see the straight sinus coming back. I can see transverse sinus going on the side like this. So these are the major sinuses which you can easily appreciate here. Before I make you draw this, I want you to see this transverse section of the cranial cavity so that it will be easy for you to understand while you draw. Look here guys. And please focus only on the posterior cranial fossa. I'm just hiding the rest of the part. Let's focus on the posterior cranial fossa. Clearly, can you see the vein of Galen there in the transverse section? That vein of Galen, now it is continuing as what sinus? That is the straight sinus. That's a straight sinus here, and that is the confluence of sinus here. This is the right transverse sinus there, and that is the left transverse sinus. And because of this side, they have cut the tentorium cerebelli. You can see that it is there on this side, but tentorium is cut on this side. So fortunately, I can see the sigmoid sinus also. Look at that. That's a sigmoid. So this transverse sinus is going and forming the sigmoid. But there is one very, very important thing you need to understand. When we saw the sagittal section, we simply said confluence of sinus is a point where the blood is coming from everywhere and that is being collected here. But the fact is, if you very carefully look at the straight sinus, where straight sinus goes back and the major blood of the straight sinus, it actually follows toward the left side. This straight sinus, the major blood of the straight sinus actually goes on this side, toward the left side. So I can say left transverse sinus is the main continuation of straight sinus. What about right transverse sinus? Well, this right transverse sinus you're looking at, it is coming from mainly from the confluence, and this confluence is having the maximum contribution from superior striatal sinus. So our superior striatal sinus, when it goes back, like say superior sinus will come like this and will come in this manner and will come at this point here, and then it will continue in this way. So we have a superior striatal sinus which will be coming in here, and then it is continuing mainly toward what side? Right side. So that's a question here. If the question is asked, the right transverse sinus is mainly a continuation of superior striatal sinus. Left transverse sinus is mainly the continuation of the straight sinus. It goes like this, turn to that side, superior striatal comes like this, and it goes to that side. Yes, they are all connected. They are all connected. That's why we call it confluence. But the question is major continuation. And that is the reason the right transverse sinus is larger than the left transverse sinus. May not be appreciated in this diagram very well, but the right transverse sinus is larger than the left because we have major blood coming into the superior striatal sinus. Maximum absorption of CSF also takes place in superior striatal sinus, and that's why, and it is continuing toward the right side. So obviously we have the larger sinus between the two transverse is the right one. Let's draw this thing and then we come back to this diagram to understand it even further. So if I take a transverse section of the cranial cavity, make sure to draw it slightly big because we have to show some tributaries of cavernous sinus also inside. So here's the transverse section of the cranial cavity. Let's just draw the ear so that remember we are seeing it from the top. Okay. And for the reference sake, guys, let's say here we got foramen magnum. In the posterior cranial fossa, let's say this here is the foramen magnum. Straight sinus, let me just take it. This is straight sinus here, and make sure you continue the straight sinus mainly toward the left side. This is the point where the superior striatal sinus will come from above, and that will mainly go toward the right side. As I said, yes, they are also connected to each other. They are connected with each other also. Let's write in short only, guys. This is the straight sinus. I'm writing SS for the straight sinus. This is the left transverse sinus. And this one here is the right transverse sinus. Just writing for the memory, this is the continuation coming from where? From the straight sinus. The major blood of the straight sinus comes in here. And the right transverse sinus, the major blood of the superior sagittal sinus comes into. Which also tells me that the right transverse sinus is larger than the left transverse sinus. Please note that right transverse sinus is larger than the left transverse sinus. Right is larger than the left. Then we saw that transverse sinus will give off its blood into the sigmoid sinus. Let's say this here we have a sigmoid sinus. There we go. And there's a sigmoid sinus here as well, which is obviously going out of the jugular foramen. These are the jugular foramen. Keep drawing all these arrows so that later on you don't have any issue with the understanding the direction of the blood flow. Okay. So that's the arrangement in what fossa? The posterior cranial fossa. The superior striatal sinus, they took the blood even from the anterior cranial fossa and took it backward. And then straight sinus, transverse, sigmoid, and petrosal, they're all present in posterior cranial fossa. So still we have middle cranial fossa to be drained. The blood from the middle cranial fossa is mainly drained by the cavernous sinus, the largest sinus, guys, and that is present in the middle cranial fossa on both the side of pituitary fossa or sella tursina. So let's say if this here somewhere is middle cranial fossa, just use a different color so that it's easy for us to identify. That's a cavernous sinus present on the left side, and here is the cavernous sinus present on the right side. So we are looking at the two cavernous sinus here, the largest sinus. Now whatever blood comes into cavernous sinus, doesn't matter where it is coming from. Cavernous sinus is going to drain its blood via two sinuses backward. One is the superior petrosal sinus, which takes the blood to the transverse. Make sure to draw it to the transverse, not to the sigmoid. This is called as superior petrosal. And the other one is called as the inferior petrosal, which is going out of the jugular foramen. We already discussed that, and is going to form the internal jugular vein. So these are the two. Let's find out the space to liberate this one and this one. So one is the superior petrosal sinus. I'll tell you why such name is given to them. Superior petrosal sinus, which is draining where? It is draining into the transverse sinus. Which sinus drains where is the most important thing here. Superior transverse sinus, superior petrosal sinus, sorry, it comes into the transverse, not into the sigmoid. It's the inferior petrosal. It's the inferior petrosal sinus which is merging with the sigmoid sinus, or you can say draining into the sigmoid sinus, and then forming the internal jugular vein. So that's a question. These are the two separate questions which were asked already in the exam, and separately in different paper. Superior petrosal is a tributary to transverse, and inferior petrosal is a tributary to sigmoid. Cavernous sinus, that's how it is given off the blood. The reason for calling the petrosal sinus is superior and inferior petrosal because they're running on the upper border and the lower border of petrous part of temporal bone. I hope you can appreciate that in the picture also. Let me show in both the images. Now look here. In this image here we have the cavernous sinus. You can appreciate the cavernous sinus there. This is the cavernous sinus, and this is the sinus going backward toward the transverse. This is superior petrosal sinus. So when the superior petrosal sinus comes back, drains into the transverse, this is running on the upper portion of this petrous temporal bone. So we call it superior petrosal. This whole thing is a petrous temporal bone. This everything is a petrous temporal bone here. So again on this side you see this is superior petrosal sinus, and because cavernous sinus is removed from here, and look at this one which is running